All right, let's dive right into this masterclass on production-grade AI engineering. We're going to cut through all the hype and focus on one thing, the architecture that's going to power reliable AI systems, not just today, but through 2026 and beyond. This isn't just another tutorial. This is what's really happening in the field. So let's kick things off with the big question, right? The one that keeps so many engineers up at night. Why is it that so many AI agents, even the ones built on these incredibly powerful LLMs, just completely fall apart the second they have to do something with more than one step? They lose track of what they're doing, they get stuck in loops, they just fail. That's the core problem we're here to solve today. And the solution, the real answer, is a fundamental shift in how we build these things. We're moving to what we call stateful agentic systems. Now, the key word there is state. That's really just a technical way of saying memory. We're evolving from these simple, forgetful, one-shot interactions to building systems that can actually remember context, learn from what they just did, and execute on a real plan. And this diagram right here shows you everything you need to know. On the left, you've got the old way. A request goes in, a response comes out. That's it. It has the memory of a goldfish. But on the right, that's the future. It's a cyclical graph. The system can think, it can use a tool, it can update its own memory, and then it decides what to do next. It's a real thinking machine, not just some fancy response generator. Okay, so here's our game plan. We'll start with the high-level architecture, then we'll zero in on the engineering bottleneck that trips up most teams. After that, we'll lay out the 2026 production standard, I'll show you how to actually build it with graphs, and we'll finish up with a pro tip to make your systems absolutely bulletproof. Let's get to it. First up, let's talk architecture. It's so important to get this. We are moving way beyond just calling an LLM. For any serious high-stakes application you can think of, purely stateless models are, frankly, obsolete. They just can't handle the kind of complexity we need for reliable, multi-step automation. Period. But, this big shift to stateful systems, it comes with its own challenges. It introduces what I think is the single biggest engineering bottleneck right now, just trying to manage the insane complexity of these agentic workflows. This is exactly where brilliant ideas crumble into messy, broken code. And this is what that bottleneck actually looks like in your codebase. We call it the orchestration nightmare, and for good reason. It's just a tangled disaster of if-else statements, try-except blocks, and state being passed around implicitly. You can't debug it, you're terrified to even modify it, and it feels like it'll break if you just look at it wrong. This approach is a one-way ticket to failure in production. So, how do we escape this nightmare? Well, this is what we're calling the 2026 production standard. It's all about moving from those chaotic scripts to clean, predictable, deterministic state machines. And this isn't just a friendly suggestion. It's pretty much the non-negotiable best practice for building professional AI systems. Let's just put these side by side, okay? The old ad hoc way is brittle. The new graph-based control is robust and totally predictable. And why is that? Because every single state transition is explicitly defined. The old way hides the state, which makes finding bugs a total nightmare. The new way makes the state crystal clear. The old way is a black box. The new standard gives us complete visibility and control over what's happening. Okay, enough theory. Let's get practical. How do you actually build this? The answer is with graph-based systems. And we're going to focus on the industry standard Python framework for this job, LangGraph. This is the tool that lets you implement the production standard we've been talking about. And the process is actually incredibly elegant. It really just breaks down into 4 clear steps. First, you define your central state. Think of this as the agent's memory. Second, you create your nodes. These are your workers. They can be functions, tools, LLM calls, whatever. Third, you wire them up with edges, which is where you put the conditional logic that steers the whole process. And finally, you compile it all into a graph you can actually run. So here's what that looks like conceptually. See how clean this is? You have distinct nodes for making a decision with an LLM, for executing a tool, and then for routing back to make the next decision, or maybe to deliver the final answer. It's clean, it's logical, it's easy to follow. A world away from that orchestration nightmare we saw earlier, right? Now have a look at the code to make this happen. Notice how, declarative it is. We're not writing some tangled mess of if statements. We're simply defining a state graph. We're adding our nodes like agent and action, and then we define the connections between them. This code is describing what the flow should be, not all the nitty-gritty details of how to execute it. And that makes it incredibly robust and way easier to maintain. But here is the real game changer. The most crucial benefit of defining your logic as a graph is that it unlocks the superpower of observability. Tools like LangSmith are built to work with LangGraph to give you a perfect visual trace of every single run. You can see exactly which nodes ran, what data went through them, and you can pinpoint exactly where things went wrong. This isn't just for debugging, it's absolutely essential for operating AI reliably in production. And finally, let's talk about the expert tip. This is the thing that really separates junior from senior engineering. It's called in-graph validation. This is the key to moving beyond systems that kinda sorta work to systems that are truly engineered for production-grade reliability. So here it is, your pro tip. Don't just react to failures, prevent them. And you do this by creating special Sentinel nodes right inside your graph. A Sentinel node has one job, to act like a quality control checkpoint and validate the agent's state before a critical step happens. Is the data in the right format? Does this required value actually exist? If that check fails, the graph can smartly route to a fallback path before the whole system crashes. This proactive defensive design, that's the hallmark of a senior AI engineer. So there you have it. We've gone from chaotic, brittle scripts to predictable, resilient state machines, the definitive standard for building complex AI agents. The patterns are there, the tools are ready for you. So the only question left is, now that you have the blueprint for reliable AI, what complex problem are you going to solve first?